Okay, so what we're going to do next is take a look at some of the integration commands that we're going to need for integration by parts, trig substitution, and partial fraction decomposition. To begin with, let's look at the integration by parts scenario. So typically what we'll need to do is find a way to integrate a function. We're going to break it into two pieces, right? That's what we do by hand. So for instance, I would like to eventually make a statement that looks like this, let's say. Int f with respect to x. Okay, and what this is telling Maple to do is integrate some function f with respect to the variable x. And if I were to replace x with t, then I would have a t integral. Okay, so as you can see, it doesn't know what f is, but it's still trying to construct that integral. We have to tell Maple what f is going to be. And to set this up, we're going to have to add a few commands. With student is going to bring in some of our typical commands that we need to do integration. And the semicolon will just terminate that statement correctly. If I want to suppress the output of that statement, I can put a full colon and type again. And it's still storing with student and all the nice commands we need, but now it's hiding it from our site. Another one that we may need, let's see here, how do I, oops, go ahead and add a line with integration tools. And let's just take a quick look at what's in here. Okay, parts. That's for integration by parts. And I think on this list, that's the main one that we're going to need. But we will need integration by parts, so make sure to type with integration tools and do that above whatever parts of the problem we're actually going to need. Okay. Now, the next thing we need is to define something like an exponential function. And there's two different ways we can do that. There's sort of the modern way where if you have all of these nice drop-down windows, you can just go to those and select from common symbols and type in E. And then when I hit Shift and 6, that'll give me the caret, which puts me in the exponent, and I can now type in something like e to the x directly. But the more robust way to do that, the safer way to do that, is going to give us the same output, but it looks a little different. I'm going to type in exp and a pair of parentheses, and now whatever I put in here, Maple will know that that's what I'm exponentiating. So if I type in expx, it gives me the same exact output. Okay, but notice this. This is something that won't work. If I just say e of x, okay, it almost looks identical. But the problem is that if I try to evaluate now, x, let's say at 0, that works. Let's try 2. Okay, and evaluate that as a floating point number. Okay, see, it almost looks as though it's behaving correctly, but the problem is that it doesn't actually know e is the number 2.718 dot 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 when we've done it this way, when I've just typed in e2. However, if I go here and use that e, it knows that I'm taking 2.71828 and squaring it. Likewise, if I take exp and 2, okay, it also knows what I mean. Okay, so that's a very subtle thing. We don't just want to type the following, e caret 2, because it doesn't know that that's the mathematical constant e. So again, to get around that, you can either use common symbols or you can type in exp, which the latter of which I'm going to use. Okay, and so now let me begin. I'm going to define a function u is equal to e to the ax. Okay, and the next thing I want to do then is define maybe a function dv, something like sine of bx, like this. Okay, let me add a line here. And now I can define f to be u times dv. Okay. And again, if I don't want to see any of this, I can put a colon at the end of each statement, and I can only show whatever output I actually want to look at, like this. Okay. And so now finally, this int f comma x has been sitting here the whole time. Let's take a look at what it looks like now, because as you can see with the variables, f is something now, whereas before it hadn't been defined yet. So now f, there you have it. We're taking the integral with respect to x of e to the ax sine bx. And one last thing we need to look at is the difference between int with a capital I versus int with a lowercase I. If I do this command, it actually computes the integral for me. And so, in other words, when you have a capital I, it's just showing you what it is you're talking about. When you have a lowercase I, you're telling it to do the work, to do the integration. Okay?